Okay, so let's chat here on Vlogging with Log about how we express how much solute is dissolved in a certain amount of solvent. So sometimes you'll see people represent things as a percent. Sometimes you'll see, I don't know if you've heard of like parts per million, where if you cut your solution into a million pieces, this would tell you how many of those pieces is the solute. There's parts per billion, there's parts per trillion. But here in science, we like things to be a little bit more precise than that. And so we use a unit called molarity. Because what does that involve? You guessed it, moles. The unit that we use to represent it is a capital M. And to calculate it is we take the moles of solute and we put it over the liters of the whole solution. So like moles over volume, and it has to be liters specifically. So we'll kind of watch out for that as we try a couple. Let's jump right in. Let's say you had a 24.5 gram NaCl solution in 2 liters and you were asked to find the molarity of the solution. I like to write out, I know I'm solving for molarity, which is moles per liter, but this ChemX, we're extreme. Check it. I didn't give you moles, I gave you grams. It's back. We're converting. We need to take the 24.5 grams of NaCl and putting it over 1. When you add Na and Cl together in the periodic table, we get 58.44. And then I got 0.419 moles of NaCl. But the fun's not over because the question's asking for the molarity. So it's asking how many moles are there per liter, and this many moles is in 2 liters of solution. So my final answer, what would show up on a label, would be 0.21, and I would write capital M, and just to be specific, I'm going to write NaCl. So if you're ever on the street, it sounds really dumb if you say, I have a 0.21 molarity solution of NaCl. We shorten it up a bit, and the lingo that we use is, hey, I've got a 0.21 molar solution of NaCl. So anytime you ever hear anybody in chem or any science really, aside from dentistry, say molar, they're talking about the concentration of the solution. So the math isn't bad at all. Let's say here we're being asked to find moles. So molarity is moles per liter. Whoops. And if I was trying to get moles by itself, it'd be the molarity times the liter equals the moles. So I'm going to write that. I've got a molarity of 2.5. That's what that capital M is, times 5 liters. And I get that the molarity of this solution is, not the molarity, that in this solution, what did I write? 0.13? No, it's not 0.13. I can't read my handwriting on the sheet of paper here. I'm erasing because that's annoying. It is 13 moles of NaOH are present in that solution. It's ChemX. Let's kick it up a notch. What if I asked you for grams? You'd go, oh, I've got 13 moles of NaOH. Putting over 1. 1 mole of NaOH weighs 40 grams, and I got that from the periodic table. Na plus O plus H. And that gives me a total of 520-ish grams of NaOH would be in this solution, like to make that. Let's try another one. I need 27.3 grams, and I have, oh my stupid clock. Okay, it only did it once. Okay. I need 27.3 grams, and all I have to work with is a 0.15 molar solution of NaCl. So the question's asking for how many milliliters of that solution do I need to grab in order to make sure that I have 27.3 grams of just NaCl. So really what I'm going to be solving for is moles. The volume. Molarity is moles per liter. And to get liters by itself, you would do the moles divided by the molarity, gives us the liters. So we want to get there. However, I don't have moles, I have grams. So we're going to do 27.3 grams NaCl over 1 grams. I'm going to write moles of NaCl. I'm writing the molar mass is 58.44. I get that I have 0.467 moles of NaCl. But we're not done. I have to divide it by the molarity, which is 0.15. And this will give me the liters, which is 0.070 liters. But what was the question asking for again? Milliliters. So let's do one more conversion. I've got this many liters over 1. 1 liter is equal to 1,000 milliliters. So in the end, I would need to grab about 70.7 milliliters of this solution, or 70.1-ish milliliters of this solution. So we're just kind of playing with some algebra. If I looked at the last problem, in class, we actually would have spent 2 days practicing making solutions, and they use one of the fanciest types of glassware to make a solution. So if I ever was like, hey, I need you to make a 1 molar solution of copper 2 sulfate, the very first thing you would do is you would figure out how many grams you would need. So you've got the molarity, and I would tell you a volume to make, and you would calculate how many grams you would need. So you'd find that first, and then you would grab, I feel like it's a really sciencey looking piece of glassware. This is what you would see if you watched like Breaking Bad or any other, like, I don't know why I said Breaking Bad, but any other like sciencey show. They always have these flasks that have really tall, skinny necks, and those are called a volumetric flask. And the reason they're shaped like that is so you can pour the solid in and add some water to it and stand there and swirl it around to try to get it to dissolve faster without spilling any. These flasks are designed specifically for the volume you are trying to make. So if you were going to make a 250 milliliter solution, you would grab a flask that holds exactly 250 milliliters. If I wanted a 5-liter solution, I would grab a 5-liter volumetric flask. So at school, I would have showed you we have all these different sizes. And anytime we've ever done a lab where we've made or used something that's aqueous, so if you picture like our metal non-metal lab, we had to use blue copper 2 chloride. That morning back in the stock room, I was back there like mixing around solutions to make sure they were the right size. But these volumetric flasks, they're pretty expensive, and that's what we use in any kind of lab setting to make a solution. So I just want you to go and practice some molarity problems. Your quiz tomorrow is going to be on molarity, as well as a few of the little vocab stuff that we talked about in the last video. Peace.